This example is based on a rover. A rover is a space exploration vehicle designed to move across the surface of a planet or another celestial body. The rover has been described with the Capella approach, and we focus now on the physical architecture in which the main rover functions are described: turn, brake, move, park, and rover position. Thanks to the safety viewpoint implemented in Capella during the first year of the Clarity project, it is possible to define on one output flow of this architecture a feared event of type erroneous. This feared event will then be exported to Safety Architect with the functions of a physical architecture. The useful data are exported to Safety Architect from the export function, Capella to Safety Architect. It is important to select the right type of export on the second dialog box, in our example from Physical Architecture. Then, the model exported in a .sa file can be opened into Safety Architect thanks to the function import legacy SA model. The model appears in the Project Explorer view. It is editable by double-clicking on the project and then on the .aiRD file. The parent block, called Container in Safety Architect, is displaced in the Design view. It can be opened by double-clicking on it. After a quick automatic reorganization of the various blocks, we can see the blocks previously shown in Capella: turn, brake, move, park, and rover position with the corresponding input and output links. The process of safety analysis can now begin. An output of the system is added. In order to simplify the local analysis, we group here 3 rover entries into one. In general, the model is not intended to be retouched in Safety Architect except for issuing safety recommendations, for example, the need of a barrier. Note, however, that this is possible. In the block Rover Position, we noticed the feared event of the failure mode erroneous of the block output, as it has been allocated in Capella. The local analysis is performed by the use of propagation links that connect the block input failure modes to the failure modes of its outputs. In the block Park, we add an abort barrier to highlight the interest of the door and that limits the effect of a failure. When the local analysis of a block is started, it turns purple. Safety Architect also allows to express the failure modes probabilities, which are then exported in an open PSA file, provided we are talking about leaf elements of a fault tree. This is done through the view property. 3 laws have already been implemented: exponential, Poisson, and Weibull. It is important to save regularly the changes done during the safety analysis activity. The propagation is then carried out automatically by Safety Architect for either one or more selected field events or one or more selected failure modes. The tree is built in a Safety Architect specific view. It shows clearly the door end added with a barrier. Once generated in Safety Architect, this tree can be exported in an open PSA format using the dedicated export function also developed in the context of the Clarity project. The proper format must be selected. The imported tree can be automatically redesigned for a more ergonomic placement. The probability data from Safety Architect are taken into account. The fault tree tool allows to perform calculations, including the elements of minimal cuts. Safety Architect also generates automatically numerous reports, such as FMECA tables exported to XLS format, and other reports such as global analysis, generated trees, critical paths that can be exported into PDF, HTML, XLS, and DOC files.